So in this video we're going to take a look at interpreting graphs. We're going to look at how to do this question and identifying the function of this graph. So please take a moment just to note a few of the equations given. So we need to identify the main aspects of the curve we can use to solve this problem. We're going to focus on the three main points. Just the three is all we need. Sounds simple. It is with practice. So these are the 3 points where the curve intersects the axis. The x-axis where y equals 0. Here's our y-intercept. You can see that the x value equals 0 while the y value equals 2. We're looking for functions with a y-intercept of 2. So these are the roots. That's where the curve makes contact with the x-axis, so we can see that the y value equals 0. Now we're looking for functions whose roots are -2 here and 1. So now that we've identified our main points, step 2 is process of elimination. So we're going to eliminate as many of the curves as we can step by step. So first we'll use our y-intercept. We'll see in a second why we do this first. It's easy. So we can see when x equals 0, y is equal to 2. So here's a list of our functions. So to find the y-intercept, we let x equal to 0. So we put zeros in where the x's are, we sub it in. So for, say, f of x, 0 squared plus 0 minus 2. So for f of 0, it's equal to -2. Or we can look at the numbers that don't have an x in them. We can see there's an obvious relationship between the y-intercept and the numbers highlighted within the function. Right here. Easy, right? Now, so we're looking for functions with y-intercepts of +2. So we can see the two functions, g of x here and k of x, have the intercept of +2. That means we've eliminated half our options just by looking at the numbers on the end of the function and where the curve hits the y-axis. So it leaves us with two remaining options, g of x and f of x. Next we're going to look at the roots. We can see that when y equals 0, x is equal to -2 and 1. So these are the 2 points where the curve intersects the x-axis. This part's a little bit more tricky, but still not too difficult. Our remaining functions are g of x and k of x, and we let them equal to 0 because y is equal to 0 when we intersect the x-axis, because that's where the y values will equal. So first let's look at g of x. So we let it equal to 0. We choose to multiply each side by -1 to get rid of the minus in front of the x squared. This isn't completely necessary to do, but hopefully it makes the next step a bit clearer and easier. Now that our minus is gone, we'll move on. So we factorize this equation to help find when it's equal to 0. So these are our factors. You can multiply them out if you don't believe me. So here's our first factor. And we let it equal to 0 so that when we multiply it with the other factor, we get 0 as it shows here. So that equal to 0. We add 2 to both sides and find that when x minus 2 is equal to 0, x is equal to 2. Next, we do the exact same with our second factor. We let it equal to 0, so when it's multiplied with the other factor, we get 0. Then, easy as pie, we take away 1 from both sides to see that when x plus 1 is equal to 0, x is equal to -1. So be careful with your signs here. We know that 2 does not equal -2, and same goes for -1 and 1. So the roots don't correspond to what we're looking for. So we know g of x has the correct y-intercept, but the roots don't quite match up. So that means we're going to have to eliminate g of x. But that leaves us with one option. So I guess that has to be the 1. But you'll have to confirm it. So this time we'll do the exact same as we did with g of x. And you can pause the video here if you'd like to work out the factors yourself, but I'll continue on. Here's what we did. We multiplied each side by -1 to get rid of the minus in front of the x squared again. And then we factorized out the equation. So these are our factors. So following the same logic, we let x plus 2 equal to 0, and we find that x is equal to -2. Things are looking good. Now for the final time, we let the second factor equal to 0. So we found that x is equal to plus 1. So let's take a moment to check our roots here. So here they are, and they match up. So now we're sure we're right. The roots match up, and the y-intercept matches up. So back to the question, we've eliminated a and c by looking at the y-intercept. Only y-intercepts of plus 2 are allowed. And so we factorized the remaining options, and we found that at the roots of g of x didn't match up. So leaving us with k of x, which we even confirmed was correct by factorizing 2. So, thanks for watching guys, and good luck.